let's start diving into 7.1. So my hope is, in these next hour and a half, we can cover 7.1 and 8.1 and be done. That's the end of the course, because I want to review all of Thursday. I want to start going over exam 1, maybe exam 2 in class during that hour and a half, kind of run over those again, a quick review of those to help you out. I think that'd be a better use of my time. So I'm going to try to go quick today if I can and get these done, because I think it'd be more beneficial to you if I spent more time reviewing Thursday instead of still doing more new stuff. All right, so here we go. Inverse trig functions. Inverse trig. So we already had 6.4. I hope you finished that. That was due 10 minutes ago, section 6.4. So how do you do cosine inverse? How do you do inverse trig functions? Well, one thing to remember, when I do sine or cosine, normally you plug in an angle and you get out an answer, right? Like you say the cosine of whatever, 30 degrees is whatever answer, right? But for inverse cosine or inverse any trig, what happens with inverse functions of any kind is the inputs and the outputs switch, don't they? That's what an inverse function is, an inverting of inputs and outputs. So therefore what's plugged in is actually the answer, and what comes out is the angle. So keep that in mind whenever you're looking at an inverse trig question. So as I look at this one, for example, they're saying, all right, cosine inverse of root 3 over 2 equals what? The root 3 over 2 is actually the answer, and what they want from me is the angle, right? Because it's an inverse cosine question. So with that in mind, what they're really saying is they're saying, hey, the cosine of what angle equals root 3 over 2? That's really what this is saying, huh? Give me the angle, they're saying, so that the cosine is root 3 over 2. So how do we do that? Let's go to the unit circle. Here's my, again, no calculator. This will be on the part 1 of the final with no calculator. So you want to have that unit circle on your 3x5. No, I say that by instinct. Your full sheet of notes for the final. So remember, that's kind of scribbly there. Remember with the unit circle, remember we have memorized 3 spots in every quadrant, haven't we? We have 3 memorized spots in every quadrant. And for those, we look at this, okay, some angle whose cosine is root 3 over 2. Now, root 3 over 2, remember the small, medium, large? Root 3 over 2, is that small, medium, or large? Large. Remember it was root 1, root 2, root 3, all over 2. And really, this one's just a half, because root 1 is just 1, huh? So remember, it's a half, root 2 over 2, root 3, the small, medium, large. So the root 3 over 2 is large. Large. So when you see root 3 over 2, right here, you think, okay, they're saying, what angle is the cosine large? Okay, now cosine, so one more important thought. Is cosine x or y? Cosine is always x. So they're saying, all right, extra large. X value large. They're saying what angle has cosine an x value of large? So as you look at these dots, look at those 12 dots, right? 3 dots in this quadrant, 3 here, 3 here, 3 here. What dot, there's actually 2 dots. What 2 dots are over x value, not up and down, not y, but over, right or left, positive. So first off, it's to the right, because it's a positive x value. So it's among these 6 dots. Everybody good so far on that? It's not the left 6 dots, because it's not a negative x value. It's not back, it's forward, it's right. Right? Where's the x value over the largest amount? Which of these dots have the x value over the largest amount? Can you tell? This one and this one. Those x values are over a large amount and up a small or down a small, aren't they? Whereas this dot, he's not over to the right as far. He's over a medium amount. He's to the right a medium amount. This dot, he's only over a small amount and up a large amount. Huh? You see what I'm saying? Do you see the 2 dots? It's all scribbled up now. Do you see that it's really this dot and this dot that are both over a large amount? That one's up a small, and this one's over large, down a small, huh? Everybody see that? Those are the two that have x values, meaning cosine is x, sine is y, that is over a large amount. Now, why not like that dot? Well, that dot is back a large. It's back large. It'd be a negative x value, wouldn't it? And they're telling me the x value, the cosine, is positive, not negative, huh? That's why I'm not looking at these on this side at all. If they told me the cosine was negative, I would be looking over there on the left. But they're telling me the cosine is positive. The x value is positive. So I'm looking on the right, and then they're telling me it's positive, the largest amount you can go. It's to the right as far as you can go. So that'd be this dot and this dot. Good to there? See how I'm coming up with that? Now, how do I know which of those two in particular? Well, it's because of the restrictions. Have you heard of that? Do you remember that from Trig? I know y'all took Trig, but that's a pretty small, subtle point that is not talked about much. So I want to mention it briefly, or remind you, or for the first time. There's restrictions on the inverse trig functions. Because they don't want two answers, they only want one answer, therefore they restrict, and they say, no, we don't want that one. The reason is they basically say cosine is restricted to values in the top half, from 0 to 180. They restrict cosine inverse. They only want answers from cosine inverse. Your calculator, if you hit the buttons, although you can't do this on the final, but it's good to know. In calculus, you'll be using your calculator different times. Hit inverse trig. It'll only give you values for cosine inverse from 0 to 180. Even if you plug in something over here, it'll throw it back into the zone 0 to 180. It only gives you answers between 0 and 180. They restrict the answers that you can get out of the cosine inverse. I'll explain why in a minute, but let's just get used to doing these. But for now, just know that. It's restricted to the top two quadrants, 0 to 180. So the answer is just going to be this one spot right here. What is that angle? Remember, the answer is an angle, right? 30 degrees. So my answer, all said and done, 30. Oh, I got to make it radians, huh? Yeah, after all that here, let me come down. I got to convert that to radians. I'm fine on a test. 30 degrees is great. But 30 degrees is the answer. That's this dot right here, right? It's a 30-degree angle. Right? Remember, it's 30, 45, 60, and this 90 straight up. Remember how they go? So that first one's 30, 30-degree angle. That's our answer. That's where the cosine's over a large amount. How do you convert 30 degrees to radians? Do you remember? Taking any chemistry yet? Converting units. You know, whenever you want to convert, you put down below the thing you want to get. I'm going to put degrees down below. I'm going to put radians on the top. Right? You put down below what you want to get rid of. I want to come out of the degrees into radians, right? When you get rid of degrees, go into radians. So you just put down below whatever you want to get rid of. What's the conversion between radians and degrees? What is the one thing we know for sure between radians and degrees? Pi radians is 180 degrees. That's the one we use all the time, right? You want to know that one real clear and cold. Pi radians, 180 degrees. But how do I know the pi goes in the top instead of the other way? How do I know I don't want to put 180 degrees in the top, pi in the bottom? Well, because you want degrees to cancel. That's how you know degrees goes in the bottom. Does that make sense? You want degrees to cancel and the answer to be in radians. So here it is. So it's 30 pi over 180. 30 goes into 186, so it's pi over 6. That's the final answer. Pi over 6 radians is the angle whose cosine is root 3 over 2, the large positive value. Good? Questions on that? Make sense? Can we try another one? Okay. Sine inverse of negative root 2 over 2. Give it a try. Remember, this is the answer, and they're asking me for the angle, right? They're switched. Inverse functions switch. So they're saying, all right, the answer is negative root 2 over 2. Give me the angle that makes sine do that. When you're done, feel free to check your calculator so you get the same thing. You might be surprised. It's going to cast it into a certain place because of restrictions. I'll tell you. Sine inverse is restricted differently than cosine inverse. I'll explain in a minute. But is that small, medium, or large, that value? That's the medium, right? 1, 2, 3, small, medium, large. That's the medium. That's 2. That's the medium. It's negative. It's negative. Notice. And now sine, is sine x or is sine y? That's y. Right? So that's down a medium amount. Down because of negative. Right? And sine. Sine's up, down, not right, left. Cosine's right, left. If that was cosine inverse of negative root 2 over 2, I would go left a medium amount. Because cosine's right, left. But sine's up, down. Why? So I go down a medium amount. So I'm looking at the unit circle, and I'm thinking about our 12 dots, right? 3 in each quadrant. I'm thinking, okay, among those 12 dots, there should be 2 of them, and then I'll restrict it down to 1. But at first, there should be 2 dots that are both down a medium amount. So if I'm a person, walking down, I'm like Spider-Man or something here, and I'm walking down the y-axis. I'm going to walk down, down, down. My level, I'm looking right and left, looking right and left, looking right. There's the first dots I see. So that's down the smallest amount. Keep going down, down, down. These 2 dots are down the medium amount, aren't they? Those are the 2 dots we're talking about. You with me? Those are our 2 locations. Those 2 dots are both down a medium amount among the 12 dots, right? Now, because of the restrictions, we're going to say no thank you to one of those dots. Anybody know how sine inverse is restricted? It's not the same as cosine inverse is 0 to 180, the top 2 quadrants. Sine inverse is different. Anybody remember? I'd be impressed if you did. Negative pi over 2 to pi over 2? I couldn't tell where that voice was. That's yours? Very good. I am impressed. That's good. One person remembered in the other class too. That's impressive. Yeah, it's negative 90 or negative pi over 2, just like you're saying, to positive pi over 2. Yes, sine inverse is restricted to the right, and tangent inverse is the same. So you want to memorize that sine inverse and tangent inverse are restricted to the right 2 quadrants, negative 90 to positive 90, or negative pi over 2 to positive pi over 2. And cosine inverse, I'll write it again right here for you. Cosine inverse is 0 to 180, or pi radians. Those are the restrictions on those 3 inverse trig functions. I haven't given any reason why we've restricted it. I'll do that in a minute. But for now, let's just get the hang of that. So you do have to know that. That kind of comes up a lot. So therefore, we're only going to keep one of those 2 dots as my real answer. I'm only going to keep this one. I'm going to say no thank you to the other one because it's not in the restricted zone. Makes sense? So this is my answer. What is that answer then? What is that angle to there? Negative 45 degrees, right? It's down 45 degrees. It's negative because the angle goes down. That's the same as going all the way around, what, 315? But they don't want you to say it that way. They don't want you to say 315. They want you to say negative 45 because of the restrictions, which, again, I'll explain in a minute. But just know, the restrictions mean they want a negative angle. They want something between negative 90 and positive 90. That's all your calculator will ever give you. Go ahead and hit it if you want to. Hit sine inverse of that. It'll tell you negative 45 if you're in degree mode. Radian, that's negative pi over 4 if you remember. Let's convert it. So negative 45 degrees. Let's convert it. What do? You put the 180 down below because you want to get rid of degrees, right? So you get 45 pi over 180. This goes in there 4 times. Use your calculator. Pi over 4. Negative. Forget all the negative. Negative pi over 4. Does that make sense on that? The answer is negative pi over 4. Questions I can answer? Negative there. So sine inverse and tangent inverse. It'll help you to have it memorized. It comes up in calculus because you'll be doing some kind of problem and like the answer will be over here in the 3rd quadrant. You'll hit sine inverse on your calculator. Even using your, almost especially because you will be using your calculator to do trig, which is fine. I allow that too. And that also in calculus. But even using that almost makes it worse. It confuses people more. Because they'll have some angle over here. They'll hit sine inverse or tangent inverse or cosine inverse on a word problem. And it'll jump it over here. I've got that question a lot of times teaching calculus. People go, Mr. Aaron, I'm doing this on my calculator. My calculator's telling me, I know it's over here at, more than 180. And the calculator's telling me And I always say it's the restrictions. It's the restrictions on those inverse trig functions. So want to remember, sine inverse and tangent inverse are restricted negative 90 to positive 90, and cosine inverse between 0 and 1/8. It's one of the weird little things, one of the weirdest in trigonometry, is those restrictions on the inverse trig functions. Okay, so we good? So it takes a little bit of practice. Let me try that one. Cosine inverse of a half. So draw yourself a unit circle. We got our 12 dots, 3 in each quadrant. Well, now you know the restrictions, huh? Cosine inverse. Where am I even looking for cosine inverse based on the restrictions? Just between 0 and 180. I'm not even going to, so I won't even draw the bottom of the unit circle, right? We're just looking at the top half for cosine inverse. The answer is going to be between 0 and 180, right? That's the restrictions for cosine inverse. All right, so take it from there. Among those 6 dots, which one's the right one? There'll only be one answer now that we've done restriction. Which of those 6 dots has cosine inverse positive a half? Is cosine x or y? It's x. And the half, is that small, medium, or large? So small. That's x value small. Positive. So it's to the right. It's not to the left, huh? It's to the right. It's one of those 3 dots on the right, isn't it? Because it's positive x value, not negative x value. So it's one of those 3 dots to the right. It's the one that has the smallest x value. Which of these 3 dots has the smallest x value? This one. Huh. He has the smallest x value, doesn't he? So there's our dot. What's that angle? Remember, it's 30, 45, 60. So we're looking at 60 degrees. So the answer is 60 degrees. Convert that. Put the 180 down below. Pi. These cancel. 6 goes into 180 3 times. Pi over 3. We good? Is that making sense how to do these inverse trig things? Questions? All right. Yeah, 9's not one we know. 9's not a memorized value. So now there's just hit the buttons on the calculator. So tangent inverse, now you guys have a calculator. Just hit the button. They want you in radians, though. Make sure, the mode. Make sure you're in radian mode, at least on this one. They want radians. Make sure you're in radian mode. Hit tan inverse of 9. Tell me what angle, radian angle you get. 1.46. And they said round to the 100th. Yes, that'd be 2 places. Is that good? Other people getting that? 1.46? Nobody else is getting that? Yeah, get that? All right. That looks like the right value. 1.46. Good? So let's just hit the button. That'd be on part 2 there. That wouldn't be on part 1 of the final, right? Part 1's no calculator. So that you need your calculator for. That'd be a part 2 question. Is that good? I'll move on. If you have any trouble with that, come see me. Make sure you're right. If you get the wrong answer, make sure you're in the radian mode. Do the mode in your calculator. If you have any trouble, grab me after. On the TIs, there's a just like a mode button, isn't there? Just hit the mode. All right. So why do we have these weird restrictions on the inverse trig function? Why did math make it that way? Well, a couple of pieces, and this is where I enjoyed the theory, and I'm tempted to go too long here. So hold me accountable. I'm going to try to be quick without too much. You don't need tons and tons of me philosophizing about math here. So remember that inverse functions must be 1-to-1. Do you remember that? Remember if you have a function like this. Let's back up a little bit. Is that a function? No, he fails the vertical line test. Remember the vertical line test? It's been a while since we've done that. If any vertical line hits a graph in 2 points, it's not really a function. I mean, it's a picture, it's a graph, but it's not a function graph, right? It's not a function if it fails the vertical line test. You remember that? So then, okay, great. So what about something like a U-shape? So this one's not a function. What about one like this? This one is a function. right? That one is a function because every vertical line only hits 1 point. So it passes the vertical line test, right? But it's not a one-to-one function. Let me write that. But not one-to-one function because, why? It fails the horizontal line test, right? We have horizontal lines hitting 2 points. There is a horizontal line test. That decides whether it's a one-to-one function. We already know it's a function, passes the vertical line test, but it fails the horizontal line test, meaning it's not one-to-one. What is a one-to-one function? A function that there's one x value for every one y value. 1 for 1. 1x for 1y. No overlapping. Never 2x's going to the same y or 2y's going to the same x. We like one-to-one functions because they're invertible. Those are the kind that are invertible. So, for example, what is this? What does it look like? Doesn't it look like y equals x squared? Let's just pretend it is. That's what I had in mind when I drew it. So y equals x squared. Do you see how y equals x squared is not one-to-one? Because, for example, you could have, let's say, 9, and that could go with plus 3 or minus 3 squared, huh? 2 different x values going to the same y value, right? This could be over plus 3. This could be, plus 3, yeah. And this could be back 3, and this is up 9. Doesn't look like it's up 9, but anyway, we say it's up 9, right? That's what it means to fail the horizontal line test. 2 x values hitting the same height, right? Hitting the same y value. We don't like that. Why not? Because, yeah, it's a function. Y equals x squared is a function, but he's not one-to-one. So if you inverted him, his inverse, if he fails the horizontal line test, then his inverse will fail the vertical line test and will not be a function. So his inverse function won't really be a function. See what I'm saying? That's why we don't really like it when they fail the horizontal line test, because they're not truly invertible. Right? If something fails the horizontal line test, then when you invert it, the new thing is going to fail the vertical, right? Everything switches with inverse functions. So why we like one-to-one functions so much is because they're invertible, right? If they have one x for one y, if they pass the vertical and horizontal line test, something like y equals x cubed. There's y equals x cubed. Remember that old graph? That's invertible. That passes the horizontal line. Every horizontal line hits 1 point. Every vertical line hits 1 point. That's an invertible function. When you invert it, it'll also pass both the tests. It has an inverse. It's invertible. Okay. So, putting all that together, it's enough with the theory there. What did I just say? I said to be invertible, to have an inverse function, an original function must pass both the vertical and horizontal line test and be one-to-one to have an inverse. Well, hold on. So, to have an inverse function, the original must pass both the horizontal and vertical tests, right? Or the inverse is not a function. It must be one-to-one. Well, wait a minute. What does the graph of sine look like? Remember the graph of sine? We were doing that last week, right? Starts in the middle, goes up and down, up and down, up and down, back same way, forever, right? On it goes. Does that pass? Well, first off, does it pass the vertical? Yeah. Every vertical line only hits 1 point. Great, pass the vertical. It is a function. Does it pass the horizontal? Not even close. It miserably fails the horizontal line test, right? Horizontal line test doesn't just hit 2 points. A horizontal line hits infinite points. It horribly fails the horizontal line test. And you got to pass them both to have an inverse function. Well, wait a minute. We're talking about sine inverse today. So I'm saying two contradictory things, huh? It seems like. Well, I am. Right? I'm saying sine fails the horizontal line test, thus it can't have an inverse. It's not invertible. Its inverse would not be a function, because if it fails the horizontal, its inverse, sine inverse, would fail the vertical and not be a function. So why is it we're doing sine inverse when I just said sine can't have an inverse? That's why we restrict, because of that very problem. That's why we restrict. We go, the whole sine, the entire sine, he's not invertible. He fails the horizontal line test. So what do? We take the original whole sine, which goes like this. And we say, all right, we're going to restrict you. We're not going to let you fail the horizontal line test. We're going to stop you right here, right at the bottom. We're not going to let you come back up, because if you do, you'll fail the horizontal. So we're going to stop you at the bottom here, and at the top right there. We're not going to let you go back down, because if you do, you'll fail the horizontal. So stop you right there. So we just take this little piece of the sine, which goes from negative 90 to positive 90 degrees. That's why. We have to restrict the sine, or he will fail the horizontal line test and won't have an inverse. So what all that means is when we talk about sine inverse, we're really not inverting the entire sine. We're only inverting the restricted part of the sine. Same thing for cosine inverse, same thing for tangent inverse. We had to restrict them to make them one-to-one. All right, there's the theory behind it. That's why we have the restrictions. So again, sine inverse and tangent inverse, you want to memorize. Those go from negative 90 to positive 90, and cosine inverse goes from 0 to 180. We good? Questions on all that? What was that? 7 minutes of theory. That's the best I can do to keep it down. There's more mysteries there, but we'll leave that. That's the main mystery. All right. Okay, so that's a trickier one. Tangent inverse of 3. So what do we basically want to say the answer is? What's our first instinct to say the answer is? Just 3, right? Because these guys just cancel. They're opposites. They neutralize each other. They're gonzos. 3. True. Right. As long as it's in the zone. Is it in the zone? Well, let's be a little careful. This time it's a little different. That 3, is that an angle or is that an answer? Now don't judge by the wrong standard. Don't look at that 3 and go, well, 3 is an answer, because I don't see a degree symbol and I don't see a pi, so it's not radians. No, that's not reliable. They don't have to give, that could be radians. It's not degrees. I agree with it, it's not degrees. There'd have to be a degree symbol. It's not degrees. But it could be radians. Radians don't have to have a pi, right? We just answered a radian question a minute ago that didn't have a pi in the answer, right? So that could be an angle. You can't judge just based on the fact that it's a number without a pi. That could be a radian angle. How you judge is what it's being put into. What is that 3 being plugged into, immediately into? Tan inverse, right? What do you put into tan inverse? Do you put in answers or do you put out angles? Or put in angles? Answers. So it is an answer. It's not an angle because of where it's being plugged, right? 3 is being put into tan inverse. You put angles into regular tangent. You put answers into inverse tangent, right? So that 3 is an answer. It's not an angle. Therefore, it's good. Done. I don't need to worry about the restriction. It's not an angle. You with me? I don't need to worry about the negative 90 to positive 90. It's not even an angle. So it's all good. They just cancel 3. We're done. That makes sense? Yeah, that's different than the last question. Let me flash back. I think that'll help you. On the last question, you see, this was being plugged into regular tangent, wasn't it? See, they had them reversed. The order was reversed. We were putting 4 pi over 13, or negative 4 pi over 13, into regular tangent, so it was an angle. So I did need to worry about whether that angle was in the zone. Negative 90 to positive 90, right? Because it was an angle. It was being put into tangent. But this time, it's being put into tangent inverse, so it's an answer, so who cares about the zone? Yes, they cancel. 3, we're done. Good? So watch for that. Watch what it's being put into. That'll tell you whether it's an angle. We put angles into the regular trig functions. We put answers into the inverse trig functions. All right, give you a second. Try that one. Tan inverse of pi. So we would like to say the answer is pi, maybe. But anyway, we'd like to say, don't they just cancel and it's pi? Maybe, probably. But let's make sure. And how you make sure is the first question you ask is that pi an angle or an answer? Don't judge by anything other than what it's being put into. What is it being plugged into? Tan inverse. So is it an angle or an answer?
It's an answer, right? We put answers into inverse trig functions, angles into regular ones, right? It's an answer. So it's not an angle. So who cares about the restrictions? Pi, we're done. That's not an angle. That's not 180 degrees. That's not an angle. It's an answer. It's 3.14, whatever pi is, right? Good? That makes sense on that? Stop me if you want to talk more about it. You guys are a very quiet group, and so I never know whether to speed up or slow down. Let me know. Nod yes or nod no, and I will know whether to speed up. Section's super easy. You'll love it. Very easy. But these last couple things are kind of hard. So here they're giving me a function, and they want me to find the inverse function. How do I take that function and find the inverse? Let me bring it up here. So I'll just call it y, f of x, same thing. Minus 7 cosine 3x. All right. So I want to, they're saying, find the inverse function. Find the inverse. How do you find an inverse function? Yeah, you remember? It's been a while, hasn't it? Good to review for that final. We'll do much of that as we can on Thursday. You invert or switch x and y. Step 2, solve for y. Yeah, to find an inverse function, you invert. Switch x and y, then solve for y. So I'm going to trade these. So the x will go out here, the y over there. Is that good so far? Everything else stays put, huh? Everything else stays where it's at, just the x and the y switch positions. Just the x and the y switch positions. Everything else stays put. And then you solve for y. That's how we find any inverse function, not just trig inverses, right? That's how we always find inverse functions. So now we have to solve for y. So here's the wall. Y is saying, I want to be alone. Get rid of all this stuff that's next to me so that I can be alone. So what does that mean? It's like peeling an onion. Let me help you. This is kind of a little bit difficult solving here. Let me help you. It's like peeling an onion. How do you peel an onion? You start on the outer layer. You just go on down to the middle, right? So let's start out. Here's what we want to get alone, the y. So we start on the outer. Got to get rid of that negative 7. And then we'll have to get rid of that cosine. Then we'll have to get rid of that 3. And then y will be alone. So starting on the outer layer, got to get rid of that negative 7 first off. How do we get rid of that negative 7? What do we do? That's just to divide, right? Nothing fancy yet. Just to divide. Let's divide that off. Good so far? So we got one layer down. So now, next layer, we got to get rid of that cosine. Get rid of that cosine. How do we get rid of that cosine? Same thing, right? Just divide off that cosine. When you divide, you can just put it right here next to that minus 7 like that. Just get rid of that cosine. 3y is x minus 7 cosine. Good to there? Samantha, you're not happy with that?
Yeah.
What's that?
No.
You're not happy? Tell me about it.
Multiplying by cosine.
Thank you, Samantha. I hope everybody's not happy with that. That's wacko-ness. I hope it's wacko to all of you. What is this? Cosine? It's like floating alone with nothing plugged in? That's nuts, right? There's no such thing as cosine. It's cosine of an angle. It's cosine of x. It's cosine of something. There's no such thing as this floaty cosine thing. What does this mean to divide by cosine? Without what? But I see that mistake all the time. That's why I'm making it. I'm trying to do all I can to reach you so you won't make this mistake. And also, not just in my class, but as you move up to calculus, I just see that mistake all the time when I teach calculus as well. Remember, it's not multiplication. Samantha said it well. It's not multiplication. It's, right, even though there's parentheses, that's what throws us off, huh? It's parentheses, and so we think, well, it's times. Well, those parentheses don't mean multiply, right? It's not cosine times 3y. It's cosine of 3y. In other words, it's like function. I mean, it is a function. Exactly. It's not just like it is. It's like f of 3y. Cosine is a kind of function.
So's sine, so's tangent, so's natural log and regular log. They're all functions. So be thinking that way. That's why I make that toaster analogy. I'm doing all I can to help students realize this isn't multiplied, these are functions. That 3y is plugged into the toaster. He's not just next to the toaster. He's in the toaster. You can't just get rid of him by, dividing him off. He's in the toaster, right? He's plugged in. Right, you would never just divide by f, right, if you had a function to get, right? That doesn't do it, right? That doesn't, the 3y is plugged in there. Well, okay, so we don't do that. What do we do? We got to get rid of the cosine. So if we can't divide it off, what do we do? How do you get rid of a function? You apply the inverse function. That's why it's in this section. Right? What's going to get rid of that cosine is cosine inverse. And whatever you do to one side, you have no choice but to do to the other. And then they cancel. Remember, they're inverses, right? They're the poison and the antidote. They neutralize each other. Right? So if you've got a cosine you want to get rid of, you put a cosine inverse in front of it. Or if you have a sine you want to get rid of, put a sine inverse in front of it. And it cancels. That's how you get rid of a function, is you do the inverse in front of it. That's why we have inverse functions, to get rid of the original functions. So what does that do? These guys cancel, and we just have 3y. This is cosine inverse of x. Now we're almost there. Last step's easy. What do we do? Just divide, right? Divide by 3. We're done. We found, there it is. There it is. And if you can put the 1/3 in the front, or you can have it underneath. It's fine either way, whatever. I'm fine on a test either way. Question? Oh, I lost the -7, didn't I? Is that what you were saying? Just as you were speaking, it hit me that I was being crazy. Yeah, I just lost it. Sorry, thanks. Let me go back. I will fix that. Yeah. This should have been, all along, x over -7, huh? Thank you. And then from there, we had what? We had 3y is cosine inverse of x over -7. I lost that, and then divide by 3. And you can leave it that way, that's fine. If you want to put the 1/3 in the front, that's okay too. -7. It's fine either way. Whatever. Both these are good answers. I'll circle them both. Either one's fine. With Math Excel and with me. Both are fine. That's the inverse function. Is that good? So we switched x and y, solved for y. It was a little painful. There it is. Now, they're also going to ask you for some domain and range questions. Let's dive into those. They're not too bad. So the sine, remember sine graph from a couple days ago? Sine graph starts out here, goes up and down and up and down, What's the range? Well, what does range mean on a function? Range means up and down, huh? Vertical coverage. So what's the bottom and what's the top for a sine or a cosine? Same thing. What's the bottom and the top of a sine and a cosine? Yeah, -1 to +1, right? Is the range. This is the range. I'll write it sideways here. This is the range of sine and cosine. They go from -1 to +1. Now, what if you have something in front of your sine or cosine? Like, what if you have 7, like we have, right? -7 cosine. What's that -7 in the front going to do? Remember from graphing? What is that -7? Amplitude. It makes it go up 7, down 7. The minus just flips it upside down, but I don't really care about that right now. It would make the top become +7 and the bottom become -7, and it'd be upside down, but who cares? It would make the range go from -7 to +7. So that's our first answer. The range of our function f, this is f, the -7 cosine thing, is from -7 to +7. It doesn't matter that it's upside down. You always put the lower one first and then the higher one. That's what you do for intervals, small to large, always. Doesn't matter anything about the graph. Just the lowest point on the graph to the highest point on the graph. Doesn't matter where it starts. Right, is that good so far? That's the range, the vertical coverage of the -7 cosine function. So they asked me for the range of f. That's the first thing they're going to say right here, range of f. Now, then they're going to say, what's the domain of the inverse function? They're going to ask me for the domain of the inverse. Remember, domain is x's. Range is y's, right? Domain is horizontal, sideways, x's. Range is up and down y's. So what do you think? I bet you can figure this out. What do you think is the domain of inverse. I mean, how does it compare to the original function? Do you think it's the same as anything? Do you think maybe the domain of f inverse is the same as the range of f? Exactly. Because they just switched. Yeah, it's the same answer. It's that. Because the range of f is the domain of f inverse. Because range and domain switch. Because x's and y switch for an inverse function. Does that make sense? So they're just making sure you know that. It's the same answer. And then finally, they'll say, what is, well, two finallys here. What's the domain of the original function f? Not if inverse. Now, we're back to the original function. We're switching back and forth here. Domain of the original function f, domain is x's. That they handed us in the beginning. You might not have noticed it. They handed it to us right here. See how they're saying for the original function f, here's the x values. So in other words, that's the domain. X values is domain. So they handed it to me right there. So that'll be bracket, what is it? 0 pi over 3. They just gave it to me right in the question. Domain of f, x values for f, okay? They want interval. And that is going to be the same as domain of f is going to be the same as what other thing? Range of f inverse, huh? Which they will ask. And we're done. Those are the four things they'll ask. So domain of f and range of f inverse, both 0 to pi over 3. And the range of f and domain of f inverse, both negative 7 to 7. Good there? Questions? That was kind of a tough one, a lot to it. Shall we try one of those? I'm pretty sure there's one of these on the final. If I remember right, I'm pretty sure I put one of these on the final. So this is good to practice. So try it out. So first thing is find the inverse function. So take that function y equals 6 sine of 3x minus 5. Find the inverse. So you know how to find inverses, right? Switch x and y, solve for y. So x goes out there, y goes in there. Switch x and y. Now solve for y, so I want to be alone. Here's the wall, y wants to be alone. First step is to divide by 6, right? Alright, so far so good. Now, how do we get rid of that sign? Yeah. It's not really multiply, it's take the sine inverse, but yeah, you get the right idea. Take the sine inverse of both sides. Right? That's the poison antidote thing. These cancel. So we have the sine inverse of x over 6 is 3y minus 5. And now the rest is easy. Just add the 5 divided by the 3. And we'll get it alone. So sine inverse, oops, I'm running out of room here. So add the 5, divide the whole thing by 3, and y is alone. Okay, if I just skip those last two steps and jump right to it. So there's the inverse function. Questions on that one? You good with the inverse function there? And then they're going to ask us, what's the range of f? Can you figure out the range of the original function f? Yeah, because see the original function f right here f is 6 sine of whatever, blah, blah, blah. So 6 times sine means the range goes from negative 6 to positive 6, right? Because that's the amplitude in front of that sine, which instead of going negative 1 to positive 1, makes the graph go from negative 6 to positive 6. And the range of f is the same as the what? Yeah, domain of the inverse. Same thing. And then they're going to say, okay, what's the domain of the original function? And that's right here. They handed it to us. See, they're saying x values for the original function. So yeah, don't do anything difficult for that. They gave it to you. 5/3 minus pi over 6 comma 5/3 plus pi over 6. And that is the same as the range of the inverse. And there we go. We are done. Is that good? Like you can do that on the final for the big points? For the double counting final exam? You know, a couple people have emailed me. One has emailed me, one has asked me, should I go back and do some of that old homework? No way. Don't even waste your time. Don't even waste your time. I'm not sure how much time you should waste on the new homework. Think about it wisely, right? And I'm not trying to keep it secret. Points on tests are where the points are at, right? Homework points are chump change. They're almost nothing. Literally, so what I'm saying is spend your time, you got a week, spend your time going back over those old exams. Make your final go better. That's where the points are, right? One more question done right on the final is worth like 5 entire old homework assignments that you did, maybe that you skipped completely done. No, don't waste your time with old homework. Spend time going over, you got 1 week, spend time going over those old 4 exams, doing those problems again and again and again. The final is hard. I mean, it's not hard. I'm not making it harder or putting anything new, but it's just hard to remember 18 weeks. These are long semesters, aren't they? Seasons have changed while we've been in this class, right? I went to Cal Poly, it was 10-week quarters. We were in and out and done. This is 18 weeks. This is a lot of stuff to remember. A long time. So, go back and review. That's a way better use of your time. I would hardly mess with Math Excel at this point. I would probably do these new ones, make sure, because there'll be one question or two, one or two from each of these new sections. But mainly focus on those old exams at this point.
Is the range the same for both of them? Or for range?
Yeah, so range of f inverse is the same as domain of f.
Oh, it's just the inverse.
Yeah. Right. We good? All right, quickly. All right, try that one. Solve. It's basically solve for x. So it's just no graphs or anything like that. Just solve for x. Solve for x. 4 cosine inverse 2x is pi. Solve for x. So first step is just divide both sides by 4. Boom. And now what? How do I'm trying to get down to x, and I want to be low, get rid of all this stuff. I got, doing the onion peeling layers. Next layer is the cosine, go from outside to in. Next layer is the cosine inverse. Right, yes, I should draw the arrow out here. I'm trying to get rid of the cosine inverse. How do I get rid of that cosine inverse? I don't divide it, right? It's a function, so you know what to do. You do cosine. You do, and whatever you do on one side, do the other. So you do regular cosine. Does that make sense? Because cosine, regular, will cancel cosine inverse. So see how we always just do, if you have an inverse, you do the regular. If you have the regular, you do the inverse. They just neutralize each other. Right? So they're gone. 2x is cosine pi over 4. Last step, divide by 2. There we go. Now, what is the cosine of pi over 4? Yeah, you can do it on your calculator. Unit circle. Pi over 4, put in 180. That's 180 over 4. That's 45 degrees. So 45 degrees, that's right in the middle. right? And what's the cosine? Over medium, up medium, right? Over root 2 over 2, up root 2 over, both positive. So the cosine is root 2 over 2 over 2. This is the 2 on the bottom here. Right? Cosine 45, cosine pi over 4 is root 2 over 2, all over another 2. And then, how do you do fractions over fractions? The flip them thing, right? Put this 2 over 1 and flip it up. So we get root 2 over 2 times 1 over 2, which is root 2 over 4. Can you hear it's off the screen a little bit, huh? So it's going to be root 2 over 4. And we're done. Questions on that? We good with solving for x there? All right, try that one. Solve for x. So 20 cosine inverse x minus 3 pi is 2 cosine inverse of x. Treat that 20 cosine inverse and the 2 cosine inverse. They're like terms. Just subtract the 20 cosine inverse from both sides. That making sense? You know what I mean? Let me jump in. So subtract 20 cosine inverse of x, subtract 20 cosine inverse of x was gonzo. So that's 20. 2 cosine inverse minus 20 is minus 18. Right? Just like terms there, you know. 2 cosine inverse minus 20 cosine inverse is minus 18 cosine inverse. Good. And now, divide by the minus 18. Boom. What's that? Pi over 6? And last step, got to get rid of that cosine inverse. You know the drill. What gets rid of a cosine inverse? It's not dividing. It's regular cosine of both sides. Cosine cancels cosine inverse. So x is cosine of pi over 6. What is the cosine? Pi is 180. That's cosine. Yeah, it's be 30 degrees, huh? 30. So do the unit circle. 30 degrees is that first one right here, 30 degrees. That's over a large amount, up a small amount, isn't it? A large is root 3 over 2. That's the x, that's the cosine, that's the answer. We're done. Root 3 over 2. Positive. That's the cosine of 30. Good? Questions on that? Everybody okay with that? 30 degrees. Could do all that with no calculator? All right. But we'll review it just to be thorough. We've reviewed trig as you move into calculus. So, right, find the value of the 6 trig functions for theta. So we have theta in a right triangle. When we do trig in right triangles instead of on unit circles, we tweak the definitions a little bit to make it easier for us, but they're still holding the same meaning. What am I talking about? Do you remember the old way? Remember the whole SOHCAHTOA thing? Remember that? SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Remember all that? That's what you do in a right triangle. It's the same as the unit circle. I could show you real quick, guys. I want you to see we're not doing something brand new. It's just another way of saying the same thing. If you're at some angle theta, say, in the unit circle, right? Say this is your radius, and this is your x, and this is your y, right? I'm saying sine of theta is opposite y, opposite over r. See, that's the same thing. See, opposite over hypotenuse is the same as y over r. It's just two ways of saying the same thing. And same for the other trig functions as well. Right? See how when you're in a right triangle on the unit circle, you can see both definitions are the same. Saying y over r or opposite over hypotenuse is the same thing. We just always put r to be 1, right? That's what unit circle, radius 1 circle means. So then this is just 1, so y over r becomes y over 1, just becomes y. That's why we say sine values are y values, right? And cosine values are x values because cosine is adjacent. What does adjacent mean? The one next to you, like your neighbor lives adjacent to you. It just means next to you. So that would be adjacent over hypotenuse. In other words, x over r, huh? So same definitions for sine and cosine. Whether you're in a right triangle or on the unit circle, either way, it's the same thing. All right, so getting back to it then, they're saying, okay, what's the sine of theta? Sine of theta is opposite over hypotenuse, as I'm sure you knew before you took this class. Opposite over hypotenuse. So from theta's perspective, which side is opposite? Here's theta in the right triangle. Which side is opposite to the b? Good? Over the hypotenuse, call it c. Call it c. And you got to find it with a squared plus b squared is c squared to find c, huh? You with me? Sine of theta is opposite, which is b, over hypotenuse, which is c. A squared plus b squared is c squared. Because in a right triangle, right Pythagorean theorem, so that's what? 14 squared plus 9 squared is c squared. So I'm kind of running out of room. What is that? Some big number, I don't know. What's 14 squared? You guys have a calculator? What is 196? Thank you. 196 plus 81, and that's some other big number. 21 minus 4, 277. And then root it. So c is the root of 277. Good to there? Did I do that right? Yeah, that's right? So that's c. So now when we come back over here and we say, what was the sign again? Sine of theta was opposite over hypotenuse. That was b over c, right? So that's 9 over root 277. And we can't leave a root in the bottom, huh? So we got to get rid of that root. Am I going too fast? It's good?
Yeah.
Sine's opposite over hypotenuse?
The A is the opposite.
Well, from theta's perspective, A, he's touching A. But he's not touching B. Yeah, let me make the triangle a little bigger here. Just to show it more clearly. Good question. Let's be clear here. So here's the right triangle, blowing up a little bit bigger. Yeah, from theta's perspective, notice theta is between sides C and A. Those are his neighbors, right? He lives between C and A. So C and A he's touching. C is called the hypotenuse because that's the one across from the right angle. But A is his adjacent side, and B is the side across from him, right? Opposite from him. So when the sine is opposite over hypotenuse, that's B over C. All right, so, and we can't leave the root in the bottom, although we wish we could. I really don't care in a test. Multiply top and bottom by root 277. So it'll be 9 root 277 over plane 277. There's the sine. Good? And since we have to get all 6 trig functions, let's get the upside down one right now. What's upside down a sine? What's it called? Cosecant. Cosecant's upside down. Now, if you're going to flip over the sine, you could flip this one over, but then you'd have the root on the bottom, and you have to do that whole thing again. Why don't I just flip this one over before I simplify? So it's just going to be root 277 over 9, done. See what I'm saying? Flip the 1 before you simplified, so the root's on the top. You'll get the same answer if you flip this one and then get rid of the root, just a bunch more steps to be in the same answer. All right, so that's sine. They want all 6 trig functions. What's cosine? Let's do maybe one more. Can you do cosine? Let me give you a second. Crank out cosine. So what's cosine? It's adjacent, SOHCAHTOA, adjacent over hypotenuse. Adjacent is A, so that'd be 14 over root 277, good. Can't leave a root in the bottom, multiply top and bottom by root 277. So we get 14 root 277 over plane 277. And we're done with cosine. Now, and the upside down of cosine would be secant. How do we do that? We flip cosine again. Flip it back before the end there. It'd be easier. Be root 277 over 14, right? That'd be secant. Upside down of cosine. Maybe I will do them all. One more. So we'll come over here. Tangent, and then here's upside down cotan. So tangent of theta, opposite over adjacent. So that'd be easy. That'd be b over a. So that's just 9 over 14, huh? That was nice. And cotan, just flip it. 14 over 9. We are done. There's all 6 trig functions. Whoops. We got them. Questions on that? Good with all that? You knew that before this class started, huh? Anything I can answer? We good? All right. So they're giving me beta. Oh, yeah. See how they do the names? They always, they use Greek letters and English letters, and they use the same letter for the angle across from the side. So alpha is across from A. Beta is across from B. See how that works? The Greek angle across from the English side. So that's the naming scheme they'll always use, so you know what they mean when they say stuff. So they're giving me B is 5, beta is 20 degrees. Just fill that in. So beta is 20 degrees. B is 5. Now, they want A, and then they want some other stuff later too. But first off, A, little a. How do we find little a? Some kind of trig relationship, huh? Let me do it wrong a couple of times and learn with me why it's wrong, and then we'll try to think better. You might think, well, I'll just do sine of 20. Well, let's do sine of 20. That's not right. What would the sine of 20 be? Well, sine is opposite over hypotenuse, right? So SOHCAHTOA. The opposite is the 5, right? The hypotenuse is the C. And so, hey, are you doing the thing?
Yeah.
Oh, you're killing me. Last 10 minutes?
Take your time.
Oh, no, it's okay. No. All right, just a minute. Yeah, so sine is opposite over hypotenuse. 5 over C. You know what it is? I thought I got out of it somehow. I thought, well, maybe they forgot. I got the whole out. I'm just giving you a hard time. Totally fine. 5 over C. So that isn't going to work because I don't know C. I guess I could find C with that. But they're not asking me for C right now. They're asking me for A. That'll work good when it's time to find C. But right now I'm trying to find A. That won't help me find A. You might think, okay, yeah, you got to use A, Mr. Aaron, to do cosine. No, that won't work either because cosine is adjacent over hypotenuse. That would be A over C. I don't know either one of those. That'd be 2 unknowns. All right, now let's think more carefully. You've probably figured it out by this time. What you want to do is you want to look at the what you have. Whoops, I'm just scribbling over everything here. You want to look at that 20, look at that 5, and look at what you want. You want little a, right? You want little a. You need some trig relationship that connects the little a and the 5 and the 20. What trig relationship connects those three, right? Because you want two numbers you know and only one letter you don't know. So what connects the 5 and the 8 and the 20? Tangent, right? In this case, it's not always tangent, but this one's tangent. Tangent of 20 is 5 over a. So that's what's going to work to allow us to solve for the little a. Good to there so far? Don't get that tangent 20 number yet. We'll get it in a minute. It's better, easy just to leave it for now instead of having some big old decimal. Can you solve that for a little a, though? I've noticed over the years a lot of trouble solving that for little a. So let me give you a minute and make sure you can do that. A lot of trouble, like maybe 30% of the class on the final. There's usually one of these on the one of these on the final. We'll get to there and then make a mistake from there. Muff it up from there. Don't muff it up. See if you know how to solve for a little a there. Okay, so here's the mistake I've seen a lot. People go, oh, I'll just divide by that 5 on both sides. So I just divide it off the 5. That's not right. Because why? Because that a is in the denominator. This would be 1 over a, and that's still not, a's still not, right? He's in the denominator. You got to get him out of that denominator. Getting him alone means getting him out of that denominator. I mean, alone means alone in the top, right? Not in the denominator. So what do? There's a lot of things you could do. You can multiply both sides by a. That's fine. Or you could just put this over. Whoops, I'm erasing it. Don't erase it. That won't help. You can put this over 1 and cross multiply, or just multiply by a. Same thing. A tan 20 is 1 times 5. You with me? So I just cross multiply. Or you could just multiply both sides by a. That'll work just as well. Exactly the same. So now this is a tan 20. 1 times 5 is 5. Now you know what to do. Just divide by the tan 20. So there it is. Somebody have a calculator. What is 5 over tan 20? 15.7? 13.7? 2.7. Can you give me one more digit? Or rounded to two places? 7.3? Sounds right. Thank you. So that's A. Does that make sense on that? We good on that? So we got the little a. They want the little c. Well, I'll do more of that next time. We need to do our survey thing. So let's stop there.